Good day, my name is Braam Greeff. I'm a Principal Systems Engineer at the CSIR, working specifically in the Defence, Security and Mining cluster area. And I'd like to address you today regarding the research work that we've done in developing a new underground network communication capability for possible use at STOPE mining work areas of the future. I'm going to give you a presentation that looks at the development approach that we followed, some of the evaluation work that we've done at the test mine, and then communicate some of the findings and the way forward that we decided upon at the end of our work. Now, just to give you some context about what STOPE phase mining communication systems is all about, is that it's all about that last 100 meters from the infrastructure that you have to the STOPE, which is basically dark, no electricity, very rugged conditions. Typically, STOPE mining work areas are unpredictable. There's lots of non-line of sight conditions where you have to communicate. Lots of mobile activity, vehicles, mining vehicles moving around, a lot of dynamic things happening, miners moving around, material moving around. And in that context, you have to communicate, which is usually difficult for normal off-the-shelf communication equipment. Our development approach or research approach was basically focused on the following. We kicked off with a concept of operations where we looked at technologies, processes, and people and how they should work together to make STOPE phase mining communication capabilities a reality. We developed some requirements. From that, we derived a demonstration architecture, which we eventually integrated and demonstrated at a mine near Rustenburg, a KROONDAL mine, where we evaluated the technology in the STOPE area as well. Looking back to a previous research phase, we did do some initial testing at a KROONDAL mine, a different KROONDAL mine, where we only evaluated the technology in the crosscut areas, the Y channels. We didn't move into the STOPE, and we only evaluated audio and video. We didn't had data capabilities at that stage. So we decided in this research phase that we want to do data, audio and video services in our channels. Right, looking at typical STOPE mining challenges, you find a lot of challenges that current off-the-shelf communication capabilities cannot provide to you. You have a lot of diffraction as a result of obstruction. You have a lot of reflection of signals, which calling delays when the signal arrives at the receiver, and a lot of scattering. The signal is just scattered around, broken up, and normal off-the-shelf commercial technologies cannot process that to provide you a clear communication signal. Hence the need to go forward with some research. If one wants to summarize the core issue with the current core communication channels at the STOPE, is that it's basically about the bottom layer, the physical layer. And what I mean there is, if you look at the international OSI model, the bottom layer is the physical layer. Now that's a challenging part of the STOPE. The physical configuration of the STOPE is typically your challenge. For any signal, communication signal to move through there is difficult, and this is what we had to study and come up with a solution with. We decided that to go through that bottom physical layer, the modulation technique that you use is key. So what we decided on, let's use a technique called COFDM, Coded Orthogonal Frequency Division Multiplexing, which is well described in theory. And this provides you with the capability that you can modulate your information on 1,000 carrier frequencies, which you can then transmit through that physical layer. It scatters all over the place. It arrives at the receiver. There's enough sufficient intelligence at the receiver available to put that signal together for you and come up with a clear audio, data, or video stream. We evaluated this, and this worked quite well. Now, just to give you a wider context of where the STOPE phase communication system will fit into the future, the total mine infrastructure, ICT infrastructure, is basically divided into a platform, a edge tier, and the STOPE. And the STOPE communication capability will interface with the edge tier, meaning that the information at the stope needs to be interfaced with the ICT infrastructure that's already in the mine, meaning typically Wi-Fi spots, Ethernet spots, and so on. So that has to be respected. Looking at typical use cases that our mining stakeholders has given to us was that they typically need to do recording of safety related data. Typically a shift boss needs to walk around with a tablet and needs to record data and upload it immediately to the mine ICT infrastructure. That's one use case. The other one is maintenance data. Typically maintenance data that you receive from vehicles operating, very important. Then decision making. Many times management wants to go down to a stope area, have a discussion in real time with stakeholders at the surface or other places of the mine, wants to have audio, video and data service available to make decisions. That can now be done. Also interfacing with existing sensors that's installed at the stope face can now be linked up with this capability to provide that data in real time to the ICT infrastructure. And then the other thing is the connected miner of the future, where you can now connect body-worn technologies and sensors directly to the mine ICT infrastructure, which provide managers with enhanced decision-making capabilities, which was not possible in the past. Right, so we came up with a possible architecture that we wanted to evaluate, and we decided that you typically have two channels. One is the crosscut channel, which is your bigger channel where your vehicles and mining machinery and people are moving up and down. And then you have your stope areas where there's typically no infrastructure, and you also obviously want to move into the stope and connect the stopes to each other. So we came up with an architecture where each miner is issued with a communication device, which weighs typically 300 grams, 200 milliwatts power usage, a video camera onto his helmet or her helmet. There's many females in the mining industry these days. A mic to the mouth, and then obviously a cell phone or a tablet that people can SMS each other. So we came up with a mesh network architecture, which now will give you the capability that to communicate between stopes and using the crosscut channel then as your main communication channel. A more detailed diagram shows the dual redundancy of the network. It's vitally important that any stope face communication capability in future must not have a single point of failure. If one minor communication device is for some reason dysfunctional, there must be alternative paths for your signal, giving your whole stope mining communication capability a robustness and a usability even in emergency situations. After we defined a dual redundant mesh architecture, we installed it in a test mine, KROONDAL test mine, which is a chrome mine, and the capability or the level that was made available to us was a stoped area as depicted there in the figure, where we wanted to evaluate two things basically. The first one is a line of sight distance. We wanted to determine a maximum line of sight distance, and the only distance that we could get out was in the region of 300 meters, maybe 350 meters. And we also wanted to evaluate when you have non-line of sight movement of miners between stopes, as depicted there on the figure, that you still want to retain communication while miners are moving around and you don't have line of sight conditions. We were successful in both areas. The 350 meter line of sight was no challenge to us. We maintained video, data and audio services clearly while miners was moving up and down that channel. And then we had some roving miners. We used the test procedures where we let miners walk around stope pillars in the mine, and then continuously monitoring the signal quality and the service quality. And the results were quite encouraging, where we kept contact, we can say 90% of the time. And the wonderful thing is the mesh network is self-healing, self-forming, meaning if you lose comms for a second or two, there is some the system then finds alternative paths from other miners in the vicinity, providing that you do that dual redundancy to you. We evaluated that capability and it actually works quite well, which means you now put the capability in the miner's hand to decide the best mesh network configuration for their work area, and you can change that dynamically, which is quite powerful. Okay. The test at KROONDAL mine, how we set that up is we installed a transmitter receiver systems hanging from the roof. The height of the crosscut was fairly low, in the region of 1.5, 1.6 meters. So we suspended the transmitters from the roof in the middle of the channels, and then the roving miners, we gave them actually rucksacks, and we mounted the lightweight mobile communication devices onto the rucksacks with a long life battery in there, and they used that to move around while we monitored the activity. And as I said earlier, that line of sight, non-line of sight conditions was quite impressive. 350 meters without intervention of other units was possible. And the non-line of sight conditions is actually endless if you use the mesh capability of the technology. We also measured some signal to noise ratios measurements, and what we've seen along the communication paths is that our signal to noise ratio stayed almost constant with very little interference. The signal quality was always excellent, and if you do get an interruption, it's typically 2-3 second interruption for the network to self-heal and find new pathways, which was quite interesting. Just a slide on the future perspective of the connected miner. We do foresee that miners in future will be connected individuals, and that implies that their PPE, when they receive their PPE at the surface, it will also contain all the technologies they need to be connected at the stope without any extra effort from them. They basically just switch on their equipment, wear their PPE, and they can function in a connected way, which means is that management decision making is sped up, more effective, and more focused. I thank you for that. Any questions?